Hello and welcome to Simplifying Radical Expressions. All right, to simplify radical expressions, we are going to use a couple of rules. The first rule we will use is the product rule. It says that if we're multiplying radicals that have the same root, dealing with real numbers, of course, then we can put both of those factors underneath one root and multiply them. So we can either put them together or leave them separated. That's the same thing that goes for the quotient rule. If we have everything on a fraction underneath one radical, then we can separate that radical over each one of those numbers there. So use the product rule to multiply. So to multiply the square root of 7 times the square root of 2, since they are both underneath the square root symbol, sorry about that, then I could rewrite that as the square root of 7 times 2, all underneath one radical. Then I can multiply that out. Now you want to make sure to check to see if you can simplify any of these radicals. 14 is only 7 times 2 in prime factorization, so I cannot simplify that. But you want to check to make sure to see if you can simplify. All right, the cube root of 4 times the cube root of 9. Well, that's the same thing since they're both under the cube root as the cube root of 4 times 9, which is the cube root of 36. Again, you want to check to see if you can simplify. So I want to do my prime factorization of 36 to see if I could get a group of 3 numbers that are alike. And you see that I don't. I have 2 times 2 times 3 times 3, so I cannot simplify the cube root of 36. So I'll leave it like it is. What about the square root of 7 over x times the square root of 2 over y? Well, I can't simplify any one of those individually, but I can combine those underneath one radical. So the square root of 7 times 2 over x times y. Then just multiply those out. 7 times 2 is 14. And you're about to see in a minute that if we could have simplified either one of those individually, then we could split that up and make the square root of 14 over the square root of xy. But since I cannot simplify either one of those by using the square root, then I will leave it just like that. All right, so using the quotient rule. Now, 6 is not a perfect square, and 49 is a perfect square. So I could rewrite this as the square root of 6 over the square root of 49. I cannot simplify the square root of 6. However, the square root of 49 is a perfect square, and that's just 7. What about the fourth root of x to the third over x to the 16th? Well, if your exponent is smaller than your root, then you cannot simplify that part either. So I can't take the fourth root of x to the third, or I can't simplify it. So I'm going to leave it just like it is. However, I can simplify the fourth root of 16. Remember, 2 times 2 times 2 times 2 is 16. Therefore, the fourth root of 16 is simply 2. So my final answer would be the fourth root of x to the third all over 2. So using the quotient rule, you can simplify or separate that square root symbol to your numerator and your denominator. All right, now what about the square root of x squared y over the square root of 100? Let's use our quotient rule to separate that. Now, the square root of x squared y. I can take the square root of x squared because that is a perfect square. The square root of x squared, remember, you just divide the exponent by the root, it's x to the first power. However, I cannot simplify the square root of y, so it will stay underneath my radical. What about the square root of 100? What do you multiply times itself to get 100? Yes, that's the perfect square, so you multiply 10 times itself to get 100. Therefore, the square root of 100 is 10. That would be the answer to that problem, x times the square root of y all over 10. Okay, what about the cube root of z to the 7th over 27x to the 3rd, the negative on the outside? Well, you would leave that negative on the outside, and let's separate the numerator and denominator with that cube root. Now, z to the 7th is not a perfect cube root. However, if that exponent is larger than the root, then it can be simplified. So let's start with the denominator because that's fairly simple. The cube root of 27. What do I multiply times itself 3 times to give me 27? Well, 3. 3 times 3 times 3 is 27. The cube root of x to the 3rd. I can divide that 3 divided by 3 to give me x to the 1st. So my denominator would just be 3x. It was a perfect cube. However, my numerator is not a perfect cube, but the exponent is larger than the root. So to simplify that, I'm going to rewrite z to the 7th. I want to rewrite it in terms of a number that would be a perfect cube, an exponent that would be a perfect cube. And remember, we use division to simplify exponents and roots. So if I start with 7, the next smaller number that is divisible by 3 would be 6. So I can rewrite this as z to the 6th times z to the 1st. That is still z to the 7th. However, what that allows me to do is to take the cube root of z to the 6th. By using division, 6 divided by 3 is 2. That will give me z squared outside of my radical with z to the 1st left inside of my radical. All over 3x. So again, if the exponent is larger than the root, but it's not perfectly or evenly divisible, then you start counting down until you find a number that is evenly divisible by that root, and then rewrite your original base and exponent in that form. Okay, I hope you found this video to be helpful. Thank you.